In this episode, we'll be checking out infrastructure automation with Terraform. We'll look at what it is, why you might want to use it, and then walk through a couple examples. Terraform is an open source project that has a well established reputation as being one of the leaders in infrastructure automation. It also has a really active community too, both in people adding new features along with pretty good documentation and a rapid release cycle. This comes in handy if you get stuck, in that if you Google around, you'll likely quickly find some examples and a solution. There's also an enterprise offering too, with support and some added features around team collaboration. It probably makes sense to back up for a minute though, and give you a high level introduction to the concept of infrastructure automation along with the problem Terraform is trying to solve. There's a pretty cool site called AWS Architecture Center where they give you a bunch of reference architectures for various workloads you can run on AWS. If we scroll down here, there's a bunch of patterns for web hosting, batch processing, and fault tolerance. If you've never seen these before, you can actually learn lots just by reading through these. Let's check out the web hosting one here as I want to use it as an example. Say you want to deploy this reference architecture for a project you're working on. How do you actually do that? Well, maybe you log into the management console and start using the web interface to create things like the front end web servers, then the application servers, and wire things up to the database. Next, you add a load balancer, etc. You get the idea. You just start working your way through it manually. I just wanted to make a side note here before we dig any deeper that I actually don't see anything wrong with using the web interface to do this stuff manually. It's pretty easy, fast, and gets things wired up really quickly. I use the web interface all the time myself. But you could also use the AWS command line tools. Say, for example, you already know what you want to do, and you've created a set of documented steps for yourself, commands that you can run for spinning up this architecture. Both these are actually great options that I use. But as you likely guessed, there's a third option too, besides using the web interface and command line. This is where you get into infrastructure automation tools like Terraform. Basically, Terraform is a tool that allows you to find what an architecture looks like via a set of configuration files, and then you ask Terraform to go build it for you. To add context to the types of tools Terraform integrates with, let's quickly check out the document site for a second. Under providers here, you can see Terraform works with a ton of folks like AWS, Google Cloud, Azure, VMware, DigitalOcean, GitHub, etc. It's actually pretty crazy. Just scroll through the list here and you'll totally find tools that you use too. Okay, so it probably makes sense just to show you a live example, as we'll likely flesh things out here. So let's switch over to AWS and run through an example using them. So I'm logged into the AWS web console. I'm using the Oregon region, which is US West 2. What we're going to do is spin up an EC2 instance using Terraform from the command line. As you can see, I have no EC2 instances running right now in this region. Just a heads up here, I've created a Terraform AWS user by going into my security credentials here. I gave this user the Amazon EC2 full access permission. I also copied the API access and secret keys for that Terraform user so we can use them in our examples. This will allow us to remotely control AWS using Terraform. Put a link in the episode notes below to the steps where you can do this too. In my editor, I have a Terraform config file loaded here. This format is called HashiCorp Configuration Language, or just HCL. You can see it's pretty simple. We have a block where we define the provider as AWS, and then put in our newly created Terraform user's access and secret keys. I just blanked mine out for sample values here. I also specified the AWS region as US West 2, or Oregon. This next block here defines that we want an EC2 instance, Web1, using this AMI and instance type. Let's jump over to the command line. You can see my two examples here. We'll cover both these today, but I'm just showing you example one right now. Before we dig in though, we should probably download Terraform. It supports Mac, Windows, Linux, and a handful of others too. You can easily find the download links on their website. I'm just going to unzip this. It's a statically linked binary. Typically, you'll see people copying this binary to a system or user bin directory so they can access it from their path, but I'm just going to use it locally today. You can see we're running version 0.11.11, but everything we covered today should apply down the road too. We can also verify this is an executable file and not some script. I like to use this file command whenever I'm curious about a particular file type. Then if we run Terraform without any options, we'll get the help menu. There are a handful of command line options you'll likely use on a daily basis if you get going with Terraform. There is the init command. This will download dependencies Terraform sees in your code to support various functionality. There's also the plan option. This will parse your Terraform files to do a read-only check on the current state in AWS and then tell you what it'll do. You can think of this sort of like a dry run without actually doing anything. Next, there is apply. This will take your Terraform configuration changes and apply it to your infrastructure. In our case, we wanted to create an EC2 instance. What's cool about this is that we can run Terraform apply over and over, and Terraform is smart enough to track its own changes via a state file. So this will not create duplicate instances, only what we asked for, which is pretty nice. Next, we have destroy. This can be used to delete infrastructure we've created with Terraform. Say, for example, that we go and spin up all of our examples using Terraform, and then we want a way to delete everything that we created. This is how you do that. Finally, there's this show command, which allows you to inspect the state Terraform knows about your environment. Okay, so now that you know the basics, let's go into our example1 directory. In here, we have our main.tf file. The tf extension, as you likely already guessed, defines a Terraform file. I should also mention that in another window off the camera here, I've updated the access and secret tokens for our AWS user in this configuration file. I just didn't want to show them on the screen. Our goal here is to create this AWS EC2 instance. Let's just quickly verify we have no instances running by checking the AWS console again. Yep, no EC2 instances running here in US West 2. But let's change that. When running Terraform for the first time, you'll typically run Terraform init. This will parse the TF files in the current directory looking for any dependencies it needs to download. For example, we need an AWS module here that knows how to connect to AWS using our keys to create our infrastructure. As you can see here, Terraform downloaded a provider plugin for AWS version 159. Worth mentioning is that the AWS plugin is downloaded into a .terraform directory. You don't need to know this for anything, but I was just wondering where it went, so I thought I'd share it with you. Next, let's run Terraform plan. This will parse any Terraform files, along with connecting to AWS and gather the current state. And then Terraform will come out with a plan of what it thinks needs to happen. One very cool thing about Terraform is that it gives you these colored symbols that help you quickly visually figure out what's happening. You can see that we have this green plus sign. That means that we're going to create something. Then we get into the actions Terraform wants to take, which is creating our EC2 instance, using the AMI and instance type we selected. You'll often see lots of these computed values here. This just means that Terraform doesn't know the values yet, but as things are computed, they'll eventually get figured out. For example, we don't know the instance IDs yet because they haven't actually been created, so this sort of makes sense. Then down here, we get a summary of what's going to happen. This is pretty simple change, but imagine you were deploying a big architecture. This can be used as sort of a nice sanity check. Now let's run Terraform apply to execute our changes. This should actually already look familiar, as we're generating a plan of what Terraform thinks needs to happen, and it's asking us to confirm it. I'm just going to type yes here. Behind the scenes, Terraform is now connecting to AWS and deploying our infrastructure changes that we asked for. Let's change over to the AWS console and see if our instance was created. I'm just going to refresh the instance list here. Pretty awesome, right? We have our instance here and it's initializing some checks. But what about making changes to this instance? Let's jump back to the editor for a minute. So in this block here, we have our Web1 instance that we just created. Maybe I want to visually see in the console what this instance is. So I'm thinking, hey, we add a tag to this instance called web1tf by uncommenting this. By the way, you can find the supporting syntax for all these blocks on the Terraform website. The docs are very good. So I'm going to save this and we'll jump back to the command line. I just wanted to recap. We now know what Terraform init, Terraform plan, and Terraform apply mean. But I've never shown you Terraform show. So let me do that now. This option basically dumps out the resources Terraform is keeping an eye on. It knows about our Web1 instance here, the instance ID, network information, etc. This data is all cached in a state file here that Terraform maintains. I'd be a little careful about where you put this file as it likely contains private details about your infrastructure's inner workings. So let's go ahead and change the Web1 instance tag by running Terraform plan. And now Terraform gives us back this update in place summary for Web1, saying, hey, I'm going to update the tags for this instance name. You'll also notice that Terraform already knows about our Web1 instance since it's tracking it in that state file. So we're only going to update this instance, not create a duplicate or destroy and recreate our Web1 instance or something like that. I often see a recurring pattern with Terraform in that you pretty much always run Terraform plan to review the output and make sure it makes sense before running Terraform apply. Okay, so the change looks good. Let's just say yes and make it so. Cool, it says it's updated, but let's verify it in the console. So we've proved things out from the perspective of creating and updating things, but what about deleting them? Well, let's hop back to the command line and delete this Web1 instance. We do this by running Terraform destroy. So Terraform is going to go out and refresh the state, and it'll come back with an action it wants to take. And you can see it wants to delete something, our Web1 instance. That looks okay, so let's delete it. You can see the status is updated, but let's check in the web console to see if it's actually being updated there too. Yep, our instance was terminated. Back at the command line, it looks like Terraform says it was successfully deleted too, as we already verified via the console. Easy enough, right? And hopefully this shows you the power of Terraform, albeit through a very simple example. So honestly, that's the basics of Terraform. That's probably 99% of what you're going to do on a day-to-day basis if you're using this. You run Terraform init to download any of the supporting packages that you're attempting to use. Then you'll use Terraform plan. If that looks good, then you'll run Terraform apply. And you'll sort of get into this continuous cycle of planning and applying your infrastructure changes through configuration files. This is where the term infrastructure as code fits, as you're basically describing your infrastructure as code. Very much like configuration management, but for infrastructure. Then eventually, we might destroy it. Sure, this seems cool, but why use Terraform? It sort of seems like a lot of upfront work. Well, I want to spend a few minutes and just sort of chat about this topic. Basically, I wanted to chat about a few places and conditions where using infrastructure automation can actually save you tons of time and reduce your stress level. Take this architecture, for example. Maybe this is a mobile game company and you're hosting a backend user database along with a store where people can purchase stuff all in the cloud. You have tons of user traffic hitting your clusters. You have a handful of developers, operations, and some data science folks. What are some of the reasons you might want to use infrastructure automation here? Maybe you're doing things manually today. To be honest, I do this sometimes too. I'm not trying to force automation on everyone. I'm just saying, hey, it might save you some time. Say you're chatting with the CTO and he mentions that traffic is growing and they're planning on hiring more developers and they want to start doing some load testing for a new campaign they want to run. This is great. The company's finally taking off. But he's suggesting creating 3 identical clusters, one for production, one for dev test, and another for load testing that will be sort of spun up on the fly over and over as they want to test features. If you're not using infrastructure automation tools, this is going to be extremely painful, as it's potentially tripling your workload. Even if you are able to do this manually, these clusters will quickly get out of sync as configuration drifts from one cluster to the next. And that'll likely cause lots of headaches. Infrastructure automation are the types of tools that can really help here, in that it can help set these up, keep things in sync, and save you tons of time and stress. But how do you actually start using automation tools like Terraform from nothing? Well, I'd start small, build confidence in the tool. Pick something low risk where you can start to use automation and build out your skills and confidence. For example, with this storage system here, maybe you have a few buckets you need to create along with some permissions and maybe lifecycle policies. This might be a good starter project. From here, we just expand across our infrastructure piece by piece. Pretty soon, you'll have a stockpile of Terraform configuration files that describe your infrastructure. Honestly, there's already a ton of existing modules or templates out there. It might not even be that hard. You just need to check out the Terraform website. This could also sort of help you behind the scenes. As the team expanding, they're likely to request infrastructure changes to support new projects, and you can quickly adapt to their changes. Another example is where you're moving so quickly that you can't keep up anymore. The company decides to clone you. Using something like Terraform, it allows you to distribute knowledge quickly amongst team because it's documented. I also find that wiki pages quickly get out of sync. If you're using something like Terraform, your new team members can self-educate. With these Terraform files and maybe a quick whiteboarding session, you can transfer a huge amount of knowledge about your existing infrastructure. This is a pretty big bonus. And that you're also okay to forget because you have it documented somewhere. If you stash these Terraform files in something like Git, now you can generate diffs too, which is pretty awesome. Let's change gears for a second and totally think of a different use case. Maybe you're doing some training. Maybe you're helping out at a local meetup and need to create a bunch of virtual machines for students. Maybe they're doing a bunch of labs. This is also a perfect use case for Terraform. Or maybe your job requires you to do a bunch of customer demos. Again, this is also an awesome use case. Okay, so hopefully through these few examples, I've convinced you that, hey, you should at least check out infrastructure automation software if you're doing this type of stuff. So I'm sure you get the idea, so let's move on to the second demo. So let's jump back to the editor. We already looked at example 1, where we deployed a single web server. We're going to continue on this theme in example 2, but expand on things a little. Up here, we're defining our access key and region again. Then down here, we have our Web 1 instance again, but we added this user data field. This will get executed when the instance boots up. Basically, I want to install Nginx and create a default web page. We'll use this in a demo as it allows us to connect to this machine and show a web page. Next, I added this security group line. We're going to use this to define a security group for our web instance so that we can accept external traffic on port 80 via our web browser. Basically, we're opening up firewall rules here. Actually, let me just show you a diagram of what we're going to build to sort of help flush things out a little bit. We're creating two web instances, web 1 and 2, along with a load balancer that will sit in front and sort of load balance traffic. So in our Terraform scripts, we just need to define these two web servers, the security group to accept traffic, and the load balancer, then run it. So that line there adds the instance to the security group for allowing HTTP traffic on port 80. This bit here boots up the web server. This is a bit of a hack, but it works. Then down here, I'm creating a second web server instance. This is web 2. You could actually create both of these within a single block using something like a counter, but I just did it this way. Here's our security group for allowing access. Actually, you might notice something interesting here. This is called AWS Security Group, and then up here in the web server, we are referencing that security group variable ID. However, this brings up an interesting point in that we need this security group to be created before the web servers so that we can have them associated with this security group. I just wanted to show you another example of this in the load balancer block, and then I'll walk through how it works. So if we scroll down, we can see the load balancer configuration block. The interesting thing here is where we tell the load balancer what instances we want to direct traffic to. But our web server instances don't even exist yet, so we don't know the IDs. So how does this actually work? Well, Terraform will read your configuration and build out a dependency graph. For us, it looks something like this. We need to create our security group first, as our web servers need it. Then we'll create our web server instances, as the load balancer needs them. And then finally, we'll create the load balancer and reference all this stuff. That's why we're using these references and variables like this, in that we can sort of map out our dependency chain and Terraform knows, hey, I need to create this before this, and then this, and sort of link things up. This would actually be much harder if you tried to do this on your own via the command line or something like that, in that you'd be responsible for managing all the dependencies and spinning things up in the correct order. So that's sort of an advantage Terraform would have over maybe running your own scripts. Let's jump back to the command line and walk through the second example. So I'm going to change into the example2 directory where we have our Terraform script we just looked at. By the way, in another window, I've updated the access token again, just so I'm not allowing you access into my AWS account. Honestly, I'd just roll the security keys anyway, but it's probably just better practice. All right, let's run Terraform init to download that AWS provider dependency again. Just takes a second. Then let's run Terraform plan to generate a report of what Terraform thinks needs to happen, and we'll walk through it. So as you can see, we're going to create a bunch of stuff. One example is our load balancer. And again, you can see these computed values here, in that Terraform doesn't know what the values are until it runs it. A good example is these web server instance IDs here. We need the web servers to exist before we can tell the load balancer, hey, direct traffic to these instances. Next, we're going to create web 1 using our custom user data script to bootstrap the Nginx web server. And we'll do the same thing for web 2. Finally, we're going to create our security group. Yeah, looks like everything we expect to happen is going to happen. So let's run Terraform apply and make Terraform create this infrastructure for us. Again, we're asked, hey, do you actually want to do this? And I'm just going to type yes, since we know what's going to happen. Let's jump over to the AWS web console and see if we can catch some of this stuff being created. Great, we can see our two web server instances being created here. Let's scroll down a little bit and see if we can catch the security group being created. Yep, it's here too. Let's verify it's actually allowing ingress on port 80 for our web traffic. Let's finally check the load balancer. Great, we have the load balancer up and running too. Let's hop back to the instances and see if they're booted up. Great, looks like it's all up and running. This is pretty cool. Terraform was able to take that configuration file, map out all the dependencies, connect to AWS, and fire this up in, say, 30 seconds. All right, let's head back to the command line and see what Terraform says. Great, it's reporting that this was successful too. You can scroll up and there's lots of configuration messages about the progress. So it's sort of nice if you have a long script, you can sort of debug what the steps were. I think there's also different logging levels. So you can turn on a more in-depth or verbose logging level, say if something broke and you sort of want to dig into that. Let's jump back to the web console and try connecting to our two web servers. If we click on the instance name here, we can grab its external address, and then let's just copy that and try to connect to it. This is great. So Web 1 is up and running. At this point, it means we can verify Terraform correctly booted the web server 1, push the user data script which installed our web server, and our security group is working too since we're able to connect to this instance on port 80. Now let's try Web 2. Again, we'll just copy its IP address and try to connect to it. Perfect. So we have both Web 1 and 2 working as expected. I'm just going to go back to the console and we'll scroll down to the load balancer. And we'll copy this front end hostname and try to connect to it. Sweet. So that works too. We now have a complete system. Our two instances with the load balancer sitting in front. And if we hit refresh a bunch, you can see that it's splitting traffic between Web 1 and 2. Actually, let me make this bigger so it's easier to see. Now let's refresh a few times. Pretty cool, right? So just as a reference, this is what we built out. Even though this is pretty simple, hopefully it gives you a taste of what Terraform is and how it works. My personal suggestion would just be to start really simple, build confidence, and see where Terraform might help out in your day-to-day workflow. Before we leave, we should probably clean all this up, so let's jump back to the command line and run terraform destroy. This will inspect our current state, and then it asks us, hey, are you sure you want to blow away all this? We're sure, so let's do it. I just want to check the console quickly and see if we can catch any of this while it's being deleted. Yep, it looks like our instances are going down. The security group is still here. The load balancer is deleted. And the security group is gone now too. Pretty cool. But this might also be a little scary, in that with a single command, we are able to blow away a huge amount of infrastructure. So that's why I suggest sort of starting small, build your confidence of what the tool is going to do when you tell it to do something, and then you can sort of expand from there. It's honestly the worst feeling to do a deploy and then get a bunch of monitoring alerts saying that you just broke a whole bunch of stuff. Before we end this episode, I want to show you a couple links that you should check out if you're still interested in learning more. The documentation on Terraform is pretty extensive. Terraform supports all sorts of things like AWS, Google Cloud, Azure, Cloudflare, VMware, etc. Lots of these are community driven and contributed, and you can really leverage lots of things without reinventing the wheel. If you click through here, you can see tons of examples and documentation too. I also wanted to point out this Terraform learning page is really awesome. It walks you through step by step the fundamentals in depth, which is pretty nice if you want a self-paced tutorial. Finally, there's this site called Terraform Module Registry, which has tons of examples. This is where AWS has something like 700 plus modules for all the various components they have. Again, I'll have all the links in the episode notes below. I also posted my examples to GitHub, and I'll post that there too. All right, that's it for this episode. Thanks for watching. I'll see you next week.